Heat. Introduction. Heat is a form of energy because it is obtained from mechanical work, and work can also be obtained from heat. Let us know the difference between hot and cold. A cup of tea is hot. A scoop of ice cream is cold. A bowl of soup is hot. A glass of cool drink is cold. Water in a kettle is hot. Water in a pot is cold. We can say the object to be hot or cold by just touching it.
Activity. Let us now do an activity to observe the transfer of heat energy. First, take a piece of wood and a piece of metal and place them in a fridge or ice box. Make sure to leave it at rest for 15 minutes. After 15 minutes, take them out and ask your friend to touch them. When we take out both the pieces which were kept in the fridge, we can observe that the metal piece is colder than the wooden piece. From this, we can say that when we keep materials in a fridge, they become cold. That is, they lose heat energy. The wooden and metal pieces show difference in their coldness when removed from the fridge. The reason for this difference in coldness is the relation of the transfer of heat energy from our body to the object. When we touch the metal or wooden pieces, we feel that they are cold. This means that the heat energy which is present in our fingers is being transferred to the pieces, and when we remove our fingers, we don't get the feeling of coldness. This means that the coldness is a feeling which we get when the heat energy is flowing out of our body, and the feeling of hotness occurs when the heat energy enters into our body. We can confirm this by performing a simple test. Light a matchstick and bring your finger near to the flame of the matchstick. How do you feel? Yes, you feel hot. From the above activity, if you feel that the metal piece is colder than the wooden piece, it means that when we touch the metal piece, the amount of heat energy which flows out of our body is more when compared to the wooden piece. In other words, the degree of coldness of the metal piece is greater than that of the wooden piece. Therefore, the conventional definition of temperature is said to be as the degree of hotness or coldness. From the above observations, we can say that the two objects, that is, metal and wood, when taken out of the fridge, the metal piece is at a lower temperature when compared to that of the wooden piece.
Let us perform an activity. Activity. Take 3 troughs and name them as A, B, and C. Add ice-cold water in trough A. Add hot water in trough B. Add lukewarm water in trough C. Dip your right hand in trough A for 2 minutes. Dip your left hand in trough B for 2 minutes. Now dip both your hands in trough C. Right hand feels the water enters to be hot. Left hand feels the water enters to be cold. The activity proves the fact that we cannot just rely on our sense of touch to decide an object to be hot or cold. Thermal equilibrium, heat and temperature. The state of system is said to be at equilibrium state if the macroscopic variables that characterize the system do not change with time. Example: a gas inside a closed rigid container, completely insulated from its surroundings, with the fixed values of pressure, volume, temperature, mass, and composition that do not change with time is in the state of thermodynamic equilibrium. Heat. We know that a glass of ice-cold water left on the table warms up, and a cup of hot tea left on the table cools down. That is, the temperature of the body and its surroundings are different. Heat transfer takes place between the system and surroundings. Heat is a form of energy transferred between two or more systems or a system and its surroundings by virtue of temperature difference. When a body is heated, its temperature rises. Hence, heat can be taken as the cause and temperature as its effect. Activity. Take a beaker full of tap water. Dip the thermometer in water without the bulb touching the bottom of the container. Always hold the thermometer vertically. Note the reading. In another set, take a beaker full of boiling water. It is observed that the reading shows 100 degrees Celsius in the thermometer. But when the thermometer is taken out of the water, immediately the mercury level falls. Hence, a laboratory thermometer cannot be used instead of a clinical thermometer. The transformation of energy from one body to another, that is, from a hot body to cold body, is called heat. Heat is measured in joules or calories. 1 calorie is equal to 4.18 joules. A calorie is defined as the heat required to raise the temperature of 1 gram water by 1 degree Celsius is known as calorie. Temperature and kinetic energy. When a hot body, a body at higher temperature, and a cold body, a body at lower temperature, are brought into contact, then the temperature of hot body slowly decreases and the temperature of cold body slowly increases. This shows that heat flows from hotter body to cold body. Temperature is the physical quantity that determines the direction of flow of heat. Kelvin K is the SI unit of temperature. It can also be expressed on degrees Celsius. 0 degrees Celsius is equal to 273 Kelvin. Temperature in Kelvin is equal to 273 plus temperature in degrees Celsius. It is represented to convert degrees Celsius to Kelvin. Temperature measured on Kelvin scale is called absolute temperature. Activity. Take 2 bowls one with hot water and another with cold water. Gently sprinkle food color on the surface of the water in the two bowls. Small grains of food color get motion. How do they move? The grains of food color jiggle because the molecules of water in both the bowls are in random motion. We observe that the jiggling of the grains of food color in hot water is more when compared to the jiggling in cold water. We know that objects possess kinetic energy when they are in motion. As the speed of motion of particles in the two bowls of water is different, we can say that they have different kinetic energies.
The temperature of a body is equal to average kinetic energy of molecules of that body.
The average kinetic energy of the molecules is directly proportional to the absolute temperature. Activity. Let us take a container with water and heat it to 65 degrees Celsius. Take a cylindrical transparent glass jar and fill half of it with this hot water. Gently and carefully pour coconut oil over the surface of the water and both of them do not mix with each other. Put a lid with two holes on the top of the glass jar and thermometers are inserted through the holes of the lid in such a way that bulb of one thermometer lies only inside the water and the other lies only inside the coconut oil. Let us observe the readings of the two thermometers. The reading of the thermometer kept in water decreases, while at the same time the reading of the thermometer kept in oil increases. You know why does this happen? Because the average kinetic energy of the molecules of oil increases while the average kinetic energy of molecules of water decreases. That means temperature of oil increases while the temperature of water decreases. Heat is the energy that flows from a hotter to a colder body. Temperature is a quantity that denotes which body is hotter and which is colder. So, temperature determines the direction of heat flow, whereas heat is the energy that flows.